What if I told you that 1,000 years before modern telescopes, a group of radical thinkers already knew the universe was calculated? They didn't just look at the stars, they saw the math behind them. Today, we're exploring the three cosmic acts described in the Quran that laid the tracks for modern science. And Act 1 starts with a single point. Act 1. The birth. Have those who disbelieved not considered that the heavens and the earth were a joined entity, and we separated them? 21-30. This is the Ratk and Fatak, the stitching and the unstitching, the singularity and the Big Bang. Act 2. The expansion. And the heaven we constructed with strength, and indeed, we are its expander. 51-47. Not a static sky, but a stretching fabric of space-time. Act 3. The end. The day when we will fold the heaven, like the folding of a written sheet. 21-104. A finality as precise as the beginning. The big crunch. If the universe is a written sheet, it must have a grammar. The Quran states, the sun and the moon move by precise calculation. Husban. 55-5. This word, Husban, changed everything for Al-Biruni. He realized that if the heavens were calculated, then man could use math to find his place within them. Standing on a mountain in modern-day Pakistan, Al-Biruni used trigonometry to calculate the radius of the Earth. His result was so accurate, it wouldn't be bested for nearly 700 years. He didn't just believe in a calculated universe. He proved we could read the math. Al-Biruni was a pioneer of geodesy, the study of Earth's shape and size, and his work paved the way for the European age of discovery. While Al-Biruni lived centuries before Columbus, his calculations of the Earth's circumference and his theories about the existence of a landmass between Europe and Asia, what we now know as the Americas, influenced the maps and navigational charts used by European explorers. Furthermore, Al-Biruni's insistence on experimentation over theory was a radical departure from the Greek armchair philosophy that dominated Europe. This empirical approach, testing a theory with physical measurement, is the exact method Galileo used to challenge the status quo centuries later. Al-Biruni's work in comparative cultures and his objective, scientific look at history influenced the way later European thinkers like Baruch Spinoza and early Enlightenment philosophers approached sociology and the study of human civilization. But how do these calculated bodies stay in order? The Quran speaks of a divine balance, and the heaven he raised and imposed the balance, Mizan, 55-7. For Nasir al-Din al-Tusi, this Mizan was a geometric challenge. Ancient Greek models of the planets were clunky and imbalanced. Tusi knew the creator's balance had to be more elegant. He invented the Tusi couple. It was a mathematical bridge that allowed astronomers to model the universe with a precision never seen before. When Copernicus later struggled to prove the Earth moved around the Sun, he reached for Tusi's math. Without the balance of Al-Tusi, the European scientific revolution might have never left the ground. Historians have found that Copernicus's revolutionary model of the solar system used a mathematical device called the Tusi couple to explain planetary orbits. The diagrams in Copernicus's De Revolutionibus are almost identical to those found in Tusi's manuscripts from 300 years earlier. Later, Johannes Kepler used the refined planetary tables and models that grew out of the Maragall Observatory, which Tusi founded, to eventually discover that planets move in ellipses, not perfect circles. Finally, we look at the one who taught us how to look, Ibn al-Haytham, inspired by the verse in Surah Al-Mulk, "You do not see in the creation of the Most Merciful any inconsistency. So return your vision. Do you see any breaks?" 67-3. Al-Haytham took this as a divine command to test reality. He invented the scientific method. He proved that light doesn't come from our eyes, but reflects into them. He showed that the laws of light are consistent, from a candle flame to the furthest star. Before him, the Greeks believed in emission theory, that our eyes shot out invisible rays to feel objects. He conducted experiments in a darkened room, the camera obscura, to show how light rays travel in straight lines through a pinhole. He was the first to insist that a theory is worthless unless it can be reproduced through experimentation. He famously said, "The seeker after the truth is not one who studies the writings of the ancients, but the one who suspects his faith in them." He was inspired by the concept of inconsistency, tafawut. He believed that because the Creator's laws were perfect, they must be mathematically consistent and verifiable by anyone, anywhere. These men were the bridge. They took the language of the stars found in the Quran and translated it for the modern world. They didn't see science as a replacement for faith. They saw science as the ultimate form of wonder. Because once you realize the universe follows a code, you realize there is a programmer. Other European successors to the Islamic Golden Age were Roger Bacon, a Franciscan friar often credited with introducing the scientific method to Europe, who was a massive fanboy of the Golden Age scholars and studied Latin translations of Ibn al-Haytham's Book of Optics. Then there is Leonardo da Vinci, whose studies on light, shadow, and the anatomy of the eye are direct descendants of Ibn al-Haytham's work. His fascination with automata mirrors the complex mechanical engineering developed by earlier Islamic scholars like Al-Jazari. These men, Al-Biruni, Al-Tusi, and Ibn al-Haytham, were the bridge. They took the language of the stars found in the Quran and translated it into the universal tongue of mathematics. They didn't see science as a replacement for faith. They saw it as the ultimate form of worship. Because once you realize the universe follows a code, you realize there is a programmer. But this great code wasn't only being deciphered in the East. While the scholars of the Golden Age were mapping the heavens, my own ancestors, the thinkers of Mesoamerica, were looking at the same stars, finding the same logic, and building pyramids that aligned with the same divine rhythm. In our next episode, we travel across the ocean to the ancient cities of the Maya and the Aztecs. We will discover how their profound understanding of the cosmos and math mirrors the truths found in the Islamic Golden Age, proving that the search for the divine is a journey that belongs to all of us. Two worlds, two lineages, one universal truth. Join us for episode 2 of this mini-series on the cosmos, the mirror of the sky.